Welcome to Efiwe, excellence without stress.
Hi guys, this is Efiwe, where we make you to have excellence without stressing yourself. And my name still remains the same, Adigbitoluwashe. And today we'll continue with our Jamb topic, but we are going to see a different topic today, and I believe we are going to enjoy it. And today we are going to be taking a very good topic, which is factorization. Factorization. I believe we have heard the word factorization before, and today we are going to bring many Jamb questions for us to solve together in order to ease our stress from going here and there. So once you watch this video, you have full knowledge about factorization and how you can deal with your factorization with ease. So today we'll be talking about factorization. Then what do we mean by factorization? Let me share more light on that. Factorization is just a way of reducing an expression. There are some big expressions that we have in mathematics. So when you hear factorize, then you know that you are ready to reduce that particular expression to a simpler form. Let me take us through some formulas that we normally use as far as factorization is concerned. The first one that you've seen on your screen here is what we call difference of 2 square. I believe we will have heard about difference of 2 square many times, but how does it operate? And that is what I've come to show you. You can see my first expression on the screen, and that is a square minus b square. So how do I illustrate a square minus b square? We have a plus b, close the bracket, and we have another bracket beside it, and that is a minus b. Mind you, this will be the approach that we are going to follow anytime we have factorization in different form. So we should take note, or anytime we have expression in different form. So the second one is sum of 2 squares. Sum of 2 squares. So if we have difference of 2 squares, what do we mean by it? So most of the illustration in mathematics, we make use of English. So which means that you as a mathematician, you have to understand English very well. So here we have sum of 2 squares. Here in sum of 2 squares, although we normally illustrate it as this. As this. That is, if I have a square plus b square, then I can actually illustrate it as a plus b all square minus 2ab. Here we have the illustration for this factor, but we don't make use of this illustration as far as mathematics is concerned, but most of the time you see this illustration in further mathematics or advanced mathematics. But anytime you see this, we have this. So obviously I put no factor here just because oftentimes we don't normally make use of it. So here we have the third one, which is difference of 2 cubes. So which means that anytime you have 2 cubes and you have a minus in between, you have a minus b into brackets a square plus ab plus b square. We have the third one, which is the other side, sum of 2 cubes. So sum of 2 cubes still give us this illustration as a plus b and a square minus ab plus b square. So we have the last one, which I call a perfect square. So what do we mean by a perfect square? A perfect square is a type of number in which when you square root them, then it gives you an whole. It gives you an whole number or an whole expression. Take for example, if I have something like this. If I have 9 is a perfect square. Why? Because if I square root it, if I square this number will give me absolutely 3. So we have 4. 4 is a perfect square, which means that if I square root this particular number, is going to give me 2. So that is how perfect square operates. So which means that here, if I have a plus b all squared, so once I square root this whole expression, this guy cancel the square root, and I have a whole as the expression implies. So we have this back. So which means that this guy here, a plus b all squared and a minus b all squared is a perfect square. So we have a perfect square expression that can be expressed like this. So oftentimes we normally take perfect square and different of 2 square, we normally misuse them. So once we see this expression like this, a square minus b square is quite different from a plus b all square, and the way we express them is actually different. So let's see some of the things that we are going to show us today, and we go to examples. So and then we go to examples. Let's check this. We have to factorize completely. M cubed minus 2m squared minus m plus 2. We have a beautiful expression here, and we have to factorize it. What do we mean to factorize? So what we have to check here is to check what is common to them. Obviously, when you check all the expression, some of them have m, and the last one did not have m here. So which means that if everything doesn't have the same thing, then we have to get back to a method that we call grouping method. So which means that we group them according to a way that it will be easier for us to actually factorize. So that is why I have made my expression to be like this. You can see that we have the same question here. So here now we can take the first 2 and we take the last 2. We group them in such a way that when we want to factorize, it will be very easier for us. So here now we have m cubed minus 2m squared, and if you check the 2 of them here, we have m squared that is common. So which means that I can actually bring out m squared, which I have brought out here, and if I remove m squared here from m cubed here, I'll be left with m. And if I remove m squared here, I will be left with 2. So which means that I can actually bring out m squared, and my number or my expression will be reduced. Now I come to the next side. In which I have minus m plus 2. Minus m plus 2 here, what can I bring out? I can see that nothing is common to the both of them. So the idea I use is to use minus 1 to factorize. If I use minus 1 to factorize, obviously what is inside this bracket will be inside this bracket. And mind you, when you are dealing with factorization, you must make sure that the factor inside the bracket must be the same. Once it is not the same, there is a problem. So we should take note of that. Now we must make sure that the 2 bracket is the same. Once it's not the same, definitely we might get it wrong at the end of the day. So what do we do here? So you can see that my 2 bracket here is the same. Then I'm going to pick one of it, and I'm going to enclose this one and the other one. I'm going to enclose them inside a bracket. So from here now, I have this guy here, which is m minus 2, and we have m squared minus 1. So which means that I have 2 brackets already. But if you see, one has not been completely factorized. So which means that we have m minus 2, m squared minus 1. When you check very well, this m squared minus 1 can still be factorized. Now when I have something like this, we have m squared minus 1. Mind you, we have said something before that when we have a square minus b square, obviously, if you could remember very well from my first slide, I have it as difference of 2 squares. So which means that I have square here, I have square here. Now when we say difference means minus. So which means that I'm subtracting one from the other. That is different. So which means that I have square. Difference of 2 square is illustrated as a minus b and a plus b. So whenever I have any form of factorization in different of 2 square, this is how I illustrate it to make it in a simpler form. So here now we are going to have the same form, which means that this side is a square form and this side obviously it can be squared, because when I have 1 square is the same thing as 1. So here now we are going to have m minus 1 and we have m plus 1, which makes the work very easy. So here now you will see that that is what we have actually simplified the work to. You can see we have m squared minus 1 squared. So which means that I'm going to have one side as a positive side and I'm going to have the other side as a negative side. So here I can see that it's very simple and is what we can actually work with. So here we have the final result. Now we go to the next item, which is the next example. As this, you can pause the video and try to solve this on your own, and I believe you are going to get it. Now if you have solved, let's check this together. So we are asked to factorize x squared plus 2a plus ax plus 2x. So in this, we can see that nothing is common to them. X is not common because this guy here has 2a. There is no x there, but other expression has x. So which means that I cannot take my factorization directly like that. Then I go to another thing that I call rearranging, or we group them so that we can bring easy factorization. You can see that I need to switch 2a and ax here, because if I group this first two, x squared and 2a, we don't have anything common here. So which means I have to rearrange in order for me to bring an easy factorization. So here we have x squared plus ax. So you can see that x is common already. I need to factorize x. I need to bring x out, and here we have 2 that is common. You can see that the both bracket now, they are the same. So which means that whenever we are trying to factorize, we should make sure that the two brackets are the same thing. Then we bring the other one together. So that is what I have brought here, and I have a x plus 2 in this bracket, and I pick one of them. You can see this one is even very simple, and you can see that I have tried to break them down, and you can see it's very simple. Hope we understand this example. Very good. So yeah, we are going to reach another example, which means that we have a very beautiful one here that can also be illustrated. So anytime we are dealing with factorization, we should be very, very careful. Based on the rules I've given to you in the first page, that is what we are going to follow to factorize any expression that you might be given in mathematics, be it Jamb or any exam that you want to do. So from this expression that we are to factorize, you see that this one looks different, and there's nothing common. We cannot arrange them by grouping. So what do we think of? We think of some expression I gave to us. We have the part of difference of 2 squares, and we have the part of sum of 2 squares. These are basically used when you are dealing with factorization. These things are basically used when you are dealing with factorization. So how do we make use of this? So here we have 1 minus open bracket a minus b all squared. So which means that here I'm going to show you one logic here. Yeah, this is what we have as the question. We have 1 minus a minus b all squared. We have 1 minus a minus b all squared. So what do I think of? Once I see negative in between two expressions, we have 1 minus. So which means that minus is at the middle, and I will check if the two sides can take square. If the two sides can take square and we have negative at the middle, obviously we can illustrate it as difference of two square. Now let's check. One can take square. Obviously we have minus at the middle, and we have this guy here which is in square form already, so which means that I can actually illustrate this guy as difference of two squares. So what do I mean? One part we have negative, and you can see the way I've enclosed my brick bracket. So far I've used a small bracket before, although it doesn't mean, and I have another one that which we take the positive part. You can see one side is positive and the other side is negative. So this side is negative, this side is positive. This side can be positive while the side is negative. Any of the two is okay. So what do I do here when I have something like this? Then I deal with the ones inside the bracket. So here, in order to have a simplified expression, so here minus opens this bracket, so which means that we have minus a, minus times minus gives me positive, so which means I have this guy here. So here we have addition to multiply, open this bracket, we have 1 plus a minus b, because when I use addition to multiply negative, then I'm going to have my negative back. So here we have this. So that is basically what we have actually done from our slide here. So let's get back to our slide and let's see the full result. So you can see we have the same result of with what we have solved. So basically we cannot factorize anything here again, so we arrive at our result because there's nothing we can actually factor out again. You can see that it's in simpler form already, and this makes our Jamb easy to see. I hope we understand. So basically let's see some other examples so that we can actually see different way Jamb can set question. Obviously all of the example I'm bringing to your view, they are taken from our Jamb past question, so that it can be easy for us, and I make sure that it is well simplified so that we can come out in flying colors this year. That's why I normally tell you mathematics is so simple. So let's get back to the next example, which we have to factorize 9 open bracket x plus y close the bracket all squared minus 4 open bracket x minus y close the bracket all squared. Now you can see that the very first thing is that nothing is common. We have minus at the middle, so we now think we have two expressions be separated. We now think that if this guy here, which is 9, can be changed to square, and this guy here can be changed to square as well, obviously it can. So which means that we have 3 square, we have 2 square here. So which means that we can actually enclose everything inside bracket, because when I open this bracket with this power, we are going to have the same thing here. Obviously we have something here like this as well. So here also we apply difference of 2 square in order to make our work very easier and faster. So applying this difference of 2 square, we have this guy here, one side will be positive and the other side will be negative. So we open the bracket, we take the addition and subtraction, which means that here we have 3x plus 2x, which will give us 5x, and we have 3y minus 2y, which will give us y. So we have the same thing for the other side. I will actually encourage us to just check it very well before we now conclude our answer. So we can also pause this video and try to solve our own, because they normally say practice make perfection. Practice makes perfection. So wherever you see an example being shown on your screen, I will just encourage us, we should try our best before we now see our own solving, and you'll also listen to the explanation for easy assimilation. So here we go to another example. Yeah, you can see we have different dimension so as to make our work easier. So here we have a square x minus b square y minus b square x plus a square y. So obviously if we check everything, we don't have anything that is common. So what comes to our mind now is to rearrange. So how do we rearrange? We arrange purposely because so as to have a common factor to bring out, and we have a unique bracket. So Now here I have tried to rearrange, because if I take the first two, obviously there's nothing common. A is not common here, and X is not common here. B also is not common here, Y is not common here. So which means I have to rearrange in such a way that here I'm not collecting the like terms. Here I'm not collecting the like terms, obviously. What I've done here is to rearrange. So here I have my a square. Obviously is to rearrange. Here I have a square x plus a square y minus b square y minus b square x. So what is common here is a square. So I try to factor it out, and I have inside brackets x here, and we have my y here. Now you can see here that at the second part here, negative sign is common, b square also is common. So obviously when I bring out the negative sign, what will be inside the bracket will be addition, such that when I open the bracket back, I must get the preceding one I'm working with. So once you take a factor of an expression and you open the bracket back, you must make sure that it reflects from the preceding one that you are coming from, so as to have easy work and so as to get the answer correctly. So here we have our x plus y as usual, and I bring these ones to the bracket. So you can see that a square minus b square is different of 2 square already, and I have to factorize in order to make my factorization to be in 3 form. You can see I have 3 factors here. We have x plus y, a plus b, and a minus b. So obviously if you check the settings of some examples that we have been solving, it's coming from the formulas that we have shown from the first slide. So I hope that if you couldn't get some of the things here, you go to the formula, you rewind your video, and you make a reflection, or you make a you go to the first slide, you make a recap of what we have showcased there, in order to make your work easy. So I hope you understand the example. But now we are going to another example, because I brought a lot of example here today, so as to make our work easy. Oh wow, we have another example here, and as you can see, it's just the application of what we have been doing, and you can see that this will make your work easier. So which means that here we have to simplify 2a plus b all squared minus b minus 2a all squared. So obviously this one is forming different of 2 squared, because we have negative that's differentiate between that is put in between the two expressions. And once you see this one very well, you should know that this one is different of 2 squared. This is done by splitting the two expressions into equal parts, and one takes the positive and the other one takes the negative part. So here we have this. So we have 2a plus b plus b minus 2a, which means that the bracket has been opened here, and we have the same thing to this other side. So here we have minus to open this bracket. So obviously what is at the middle change to positive. So when we have 2a minus 2a, we cancel out, because 2a minus 2a obviously gives us 0, and we have b plus b to give us 2b. So obviously the same thing is done here. So b cancel out here, and we have 2a plus 2a. So you can see that when we take the multiplication, we are going to have 8ab. So you can see that this makes our simplification very simple and easy for us to actually learn. So here we have another thing for us. So we can pause this one, check how we can go, how far we can go as factorization is concerned, and we can make use of the examples that we have been dealing with before. So here we put on your screen 8a plus 125 as cube. So we factor out, because a is common to the both sides, we factor out a, and we see where we can use a cubic addition of 2 cubes, or we call it sum of 2 cubes. So you can see that we have been able to factorize with the use of addition and sum of, or you can see that we have been able to factorize the addition of two cubes, or we call it sum of two cubes, and this gives us a very definite answer. We have another one to see. We are asked to factorize completely 4abx minus 2axy minus 12bx squared plus minus 12b squared x plus 6bxy. So here we can see that 2x is common to all the expression there. So that is why I've tried to bring out 2x, and you can check out that this is true, and we factorize the one inside the bracket and we arrive at this answer. You can take your time and check. It's just the application of what we have been doing since, so we can take our time and check very well, and we see that it is true. So here we have another example. Obviously this one also is different of 2 square. We can see that this is applied with easy solving, although what makes it different is we have a perfect square here. So it is not compulsory that we illustrate it in two-fold. Sometimes we can leave our answer like this, and sometimes we can actually split them into two. So which means that at the end of the day we can have x plus 1, x plus 1, x plus 2, and x minus 2. So either of the two we can actually get our answer right. So here we move to another thing, and this is this. So which means that here we can actually take our time and check what is written here. I actually brought all these examples so that when you check one, you relate it with the other. And at the end of the day, for this example, we got bx minus 3 and 9x minus 2y. So it's more or less like the same logic that we have been doing and viewing before. This completes our class on factorization.